Hi everyone, so welcome to this video in which we'll be going to look at how to deploy, basically how to run a GPU on a Google Cloud platform. So $300 you get as free credits for all the new customers, so go ahead, utilize these. I've already done that. So if I come to my Google Cloud main dashboard, I'll see that you've activated your full account. Use any remaining credits and then pay as you go. So this expires on January 24, 2024, and which is approximately 3 months from. And I have 0 out of 33,292 credits used. So let me just go to the first thing. So we'll be looking at three things here which we have to do. The primary thing is creating a compute engine, basically a cloud computer for us, which will be having GPU inside it. But to do that, we need to have two things prior to that. One is increase the request in our quota, and second thing is uh, setting the appropriate firewall rule so that we can access it. Okay? So if we go to the IM and admin and we go down to the quotas, and then in the metrics we search for GPUs underscore all regions. So we need to actually cross check check this mark and apply the new limit. So my current limit is set to 1. For most of you it will be set to 0. It will be set to 0 basically, so you can put limit as 1 here or 4 here. I tried putting 4, but they give only 1, so if you're lucky you'll get more. But you can submit a request, after which all this will be instantaneously activated for you. So now next thing is we need to go to the security and firewall. So let me go to actually directly from here, firewall. So inside the network security we are at the firewall, and here what we want to do is create a new tag in which we open some of the ports like port 5000, port 9090, port 8888. All right, so let's see how to do that. So in here, after we come to this VPC network to the firewalls, if we'll reach here, we'll see firewall rules control incoming and outgoing traffic to any instance. By default, incoming traffic from outside your network is blocked. So what we need to do is create a firewall rule, and let's call it custom ports, allowing custom ports access, and specify targets all instances in the network or specific target tag. So let's give the name custom port again here, and what we can do is we can type 0.0.0.0/0, which means allow all the IP ranges. All right, and protocols and ports, from here we can allow all or specific protocols and ports. So let me cross check once. So we want to allow TCP ports from, let's say we can do comma separated value. Let's allow 9090, 5000, 5050, and 8888. These are some of the custom ports which we'll open, and yeah, we can click on create rule. So we've just created the firewall rule which we'll be applying to our, okay, so here you see the custom ports. So all this is allowed, action allow, priority is assigned to it. Okay, so now if we come to compute engine VM instances, and we'll create a new instance for us. So this one is which I was using for some initial experimentation. We'll click on create instance. Let's call it GPU instance, and location I'll choose as US East 4. In the GPU section, I will use NVIDIA T4 GPU. I'll choose 8 cores and 30 GB of RAM, and then I'll use Ubuntu 22.04 x86 64 version, and size I will assign to this as 200 GB. So with all of that thing enabled, it will show me the cost of around 429.76. all right, so allow HTTP traffic, allow HTTPS traffic, and advanced networking option. So network tag, forgot the name of that, custom port. Alright, so we can modify that networking thing later. That's not something to worry about. So this is our sub network. All these things are good to look at. So I'll just click on create. I'm not using the previous instances, so I can delete them. Yeah, so maximum limit is 1, so I've already utilized that one in here. So I'll just try to get that instance again after deleting this. So let me just delete the instance 6 first, and then again try to get the resource. So that was causing some issue. It was not getting refreshed, so I just created another instance. It hardly took me a minute, and yep, I have got the external IP address, the internal IP address, and I can SSH into my system. So I can open browser on custom port, open browser using provided private SSH, UG cloud command, use another SSH. So I can just click on SSH, and also what I can do is copy. Yeah, so this is my cloud right now. If I type NVIDIA SMI, I won't be able to see anything, but I can quickly install the NVIDIA related libraries by typing these two commands. So the first command is apt install. So I would prefer installing this 525 version. So I can copy this and I can paste. I need to put a sudo in front of it. And since I'll be running Docker images on this as well, so I would install NVIDIA Container Toolkit. Okay, before I do this, sudo apt update. Till the time this is running, I can, okay, so this is already completed. I can go over to my VS Code and I can actually SSH into this machine. So in order to log in into your Google Cloud from your terminal, what we can do is we can just write SSH keygen, and it will generate a public key for us, and it will generate a private key for us. So the private public key, which looks like this, so yeah, you can copy all this public key. Do not copy the username at the rate hostname, just copy it up till this point, and that you can paste once you click on the edit. You can paste it in the SSH keys, and you can see the complete ID, and you can use your email address, whatever is coming, like, you know, the username, you can just use the same username here. Alright, once you do that, once you save it, you will be able to do another interesting way of how to connect to remote servers is at SSH host, connect to host, configure SSH hosts, and what you can do is you can give it the host any name, like, you know, GCP GPU, and in the host name you have to put in the external IP address. So for me, everyone will have their own thing. The user which I am logged into is unwov.lns, and the file which I'll be using is this file, identity file. Alright, so you can save it, and next, if you connect to the host GCP GPU, it will come. So it's saying setting up SSH host on the GCP GPU, installing VS Code server and everything. So now once this thing comes, so you can be sure that you're running your VS Code. Trust the authors. So now we are inside the GCP machine, new terminal, and still you can see NVIDIA SMI is not able to work. For that, we need to do a sudo reboot. So the reboot will take few seconds. So I just noticed that my video got stuck, and that's because the battery of my camera exhausted, but not an issue. We can continue without that, obviously. Okay, so it still says it's not installed and it's failed. Alright, so let's do one thing. Let's remove all the NVIDIA packages and everything which we have, and again we'll install the drivers again. This we have already executed, so we need to execute sudo apt install NVIDIA driver. You can install 5355525. You need to make sure which drivers are compatible with T4 GPU which we have. We can just open a new GPU, and we can also new terminal, and we can type this. So it shows this NVIDIA Corporation Tesla T4. This means the GPU is available. Only thing is that drivers are not installed. The compatible drivers are not installed. So along with that, we can also install the NVIDIA Container Toolkit. For that, we need to execute these few commands here, and after that, the NVIDIA Container Toolkit will also be installed. This would allow us to actually use NVIDIA GPU inside the Docker image. So let's do a reboot now. Okay, so let's try reloading the window. It's been almost 1 minute. So open a terminal and type NVIDIA SMI. Okay, so now I can see the CUDA version, the driver version, my GPU version, everything is installed properly. Next, what we need to do is either we can run an Anaconda version here and can proceed with that, and I would just extend this to actually showing you one thing, but in fact two things. So what I'll do next is I can go to Anaconda python.com/download. I will use the Python 3.11 version, that's fine, not an issue, on the 64-bit x86 architecture. This is what we have chosen. So we can copy link address, and here we can type wget. Now we can type bash anaconda. So it will ask us to accept certain terms and conditions, which we will do. We'll type yes. So this will install the Flask, the GPU, everything inside the single thing. So my environment will be up and ready for deploying anything which I want. Besides that, in the same video, I'll show you how to how to install Vitis AI. So if we head over to the Vitis AI documentation page, and at the same time, we go to Vitis AI GitHub link. So if I open a new terminal and type conda, okay, so let me see this set conda config set auto configuration to base as false. So here is my command for conda, so I can directly use this conda list. So it will list all the packages which are now installed on my system, and I can run a Python project. I can open a Jupyter notebook. So let me, in the same video, actually what I can do is I can open a Jupyter notebook and can show you how whether the port which I'm serving it on, whether that is opening or not. Okay, so for that, let me first go to this bash rc. So there is no such thing as anaconda entry here right now, so I need to make a entry for that. So I can run this command init bash, and this it says that it has modified this file, bash rc file. So we can see the bash rc file. Yeah, so if I open a new terminal now, conda will work. Conda activate. So yeah, conda activate. So this base thing is all automatically coming up. Now I can just type Jupyter notebook, and it says that it is running on 8888, and I forwarded the port 8888. So there are two options with me right now. Either I can directly so here I can use, so I can visit the port 88. Okay, so this configuration is not done properly. I can also do one thing. So this is using port forwarding that it has taken place, and the forwarded ports, I like in the terminal you can see this is the token. So I can copy the token. This is not copying it properly. We just okay, so this is not copying it only. Okay, because I'm pressing Control C, I need to press Control Shift, where I can use copy. Okay, so now I'm inside the Jupyter notebook, and this Jupyter notebook is running on my Google Cloud platform. And yeah, I mean, neither Pytorch or TensorFlow is installed in it right now, so I can install Pytorch, TensorFlow. I can do that. Next thing which I would want to do is install Docker in this, and run Vitis AI on that. So for that, here you can just try creating new Python 3 kernel, and basically GPU, you have one GPU inside in here, which you can utilize for your Pytorch and TensorFlow app. And just a quick guide on how to install Pytorch. So we can run this command. We won't run it in the base because it will make things little messy. So I'll close the notebook, and conda create -n. Let's call this as Pytorch. So conda activate Pytorch. Now I can do pip install. I just need to do pip should already install. So it's again and is asking for same. So installing Docker also is very simple. You just head over to this website, and in here at the last page you'll see how to install Vivado, Vitis AI. If you keep scrolling down, you'll see all these commands for installing the Docker. So this why I'm installing Pytorch and anything outside is because just to launch some machine learning application or check that thing. Vitis AI is for running the FPGA users. Those who are users of FPGA will know like whom I'm referring to, basically hardware software co-design course student. Lastly, we need to add user to the Docker container, also Docker group. So if I restart the system, I'll see a Docker group also come. Okay, so let's sudo reboot. So you can see the Docker coming here now. So I can just type Docker images and can run a Docker hello world. So this Docker works in this. next what I need to do is the Vitis AI GitHub repo is git instances. So git clone, and I just need to execute the docker build command. Here you'll see inside the docker there is this docker build.sh file. So for GPU dockers, we need to build for the Pytorch version or for the TF2 version, whichever thing you want to use. You can build using. Also, don't forget to close your GCP server every time you have stopped working on. So cd Vitis AI. By the way, so that when I close this thing, my session does not collapse. So therefore, I'm using tmux right now. So I've just typed tmux, and you can see tmux ls, right? So you see that I have a session 0 running. So I can type tmux attach just tmux at a, so it will automatically take me to this. Now whatever I type in this, even if I close my ssh, this thing will keep on running. Okay, and in order to exit from this, I can press Ctrl B and then D, so I can detach from that. Okay, so I launch this inside the tmux terminal. By the way, I can press Ctrl B and star, and it will split my tmux thing as well. Okay, so I have the mouse option is not enabled in this, so for that tmux settings are there and a lot of things are there. For now, Control B O and Control B, so it is split it again. Forgot how to close it. Control B, so no session, so I'll launch a new tmux session, and I'll cd into the docker and dot sudo dot slash. So I need to provide hyphen t as GPU and hyphen f framework as I can choose TF1, TF2 or Pytorch. So let me choose TF2 right now. So this will take some time, about an hour or so, and after that our Vitis AI should be up and running on this. The only thing which would be remaining to check forward to see the complete thing would be the launching of the Jupyter notebook inside. But for that, as I've already told you, that the port which is on this Google Cloud, that is being forwarded to my local port 8888. So only thing which you need to do when launching your docker using this command docker run.sh file. So here you'll see finally they're executing this command, docker run command. You provide them with the image file, and you just need to enable port forwarding basically. So this detached it or anywhere, you can simply write the port forwarding command, which is -v. So I'll tell you which command is that exactly. So the command for that is simple. For doing the port forwarding, you just need to write -p and whatever ports you want to forward it to. So the host port and the container port. So we can transfer the port 8888 from the container to the host port, and whatever we run inside the container, that we can directly access. So I will try that out. If you have any confusions, you can let me know, but at least for now you can run all your applications, your cloud acceleration on Google Cloud Platform. So thank you for this video, for watching this video. Hi everyone. So this is the second part where I left it overnight for completion of this the whole Docker build thing. It took almost 844 seconds. I don't know how much, divide by 6. So now we have the Docker images up and running for us. So let's go ahead and execute. And as I told you, before we execute in the Vitis AI folder, I would like to go to docker run command, and where they are mentioning all these, where they're actually running the docker run, the parameters, which you can see somewhere here, right? Docker run and hyphen GPUs all, etc, etc. There I can do the port forwarding as well. Like I'll forward the port 8888 to from host to the local machine. So here there are docker params run parameters. So I can go to the docker run parameters, and here I can add one more parameter. So let's write it after here. I can write -p and forward 8080 to 88. I'll forward one port, this port, and another port which I'll forward is -p8888 to, okay. So now let's save this, and now we can cd dot slash and dot slash docker and dot sh. You need to pass in this, so along with the latest tag. So we're inside the Vitis AI, and this is inside the tmux obviously. So this tmux settings we have not done properly, so you might find it a little bit hard to scroll up or something. But rest assured, Tmux is a very beautiful tool for actually keep your instances running. So I always prefer using Tmux. Okay, so now Conda info. So you have this base Conda image itself. So if I just type Pytorch notebook and let's see by default which port it runs on. Conda activate. Better to do Conda install. Obviously this has good speed of internet, so you don't need to worry about waiting for it to get downloaded or anything. Okay, so now we've already forwarded port 8888 and this port is already forwarded. So let's try and run browser. Okay, so now in the Docker we've got this. We'll just paste the token from here. So can copy login. So now here we are in the demos folder, and like it's working as good as your local computer. So here what you can do is there are a few things which you can do. Let's go to Vitis AI GitHub documentation, or let's go to just Vitis AI GitHub and go to model zoom model list. Now you can pick up any model which you like from here. Let me try and run YOLO v3 for you. Okay, so this is TensorFlow version 3.5 only, which we have currently with us. So you can now pick up any model, and this is the GPU for this is the link for downloading all the files. I can head over back to terminal. So all the commands which I want to keep running, I put it on Tmux. On these small commands, I can run simply on the bash. Makes things easy. Vitis AI cd dem wget thing. I'll copy. So I can just type. So this is got downloaded with a weird file name. So mv2tful2.zip I forgot. So we can put unzip sudo apt install zip. So in the demos folder now you'll start seeing this thing coming. And yeah, so this is a float h5 file format, and we all know how to get the float h5 file format. Then this is the quantized h5 file format, and there is no X model file, right? So based on the code and like if you go through the readme and everything that quickly. So if you go through readme.md, it is telling you first of all Anaconda 3 TensorFlow 2.3, all these things that you have to get. So we'll create a new Conda environment. So now we again execute all of this in Tmux. So here I'm running the Jupyter notebook itself. So let me do one thing slash and this is the name. Okay, what we can do now is go to this folder cd dem. Let's create new environment for called YOLO v3-tf2 running Python 3.6. So we've activated this right now. Then we'll do pip install Python and pip install -r requirements.txt. Okay, cd tf2 YOLO v3 3.5. Here I need to pip install -r requirements.txt. Then the data set consists of 5000 images, so we can download this data set. But after running all this prepare data and download data, convert data, all these, let me just see how much time it takes download the data set. Point being, after doing all this thing and downloading the YOLO v3 weights, we'll finally, after doing all the training, we'll get this file with us. This is YOLO v3.h5 file, right? The pre-trained model file. But assuming that you'll download all of this, and getting to YOLO v3.h5 file is not at all difficult. It's like so much documentation is available on the internet. What is not available is what to do after we get that file. So for that we have a very good reference to ping DPU as always. So once we have the h5 file, how do we quantize the h5 file? So in fact, creating wheel for bokeh, so some things are failed. Anyways, you can proceed without it for now. We'll just simply follow this documentation for actually generating the X model file. We need some images with us for actually doing the quantization step, because quantization requires a calibration data. I would run then we need to also execute command tool name numpy, which is quite strange. So we have this float file with us, YOLO v3.h5 float file with us. We would directly jump to quantizing it. Okay, so let's do it inside a notebook here. Let's create a new notebook. I see what the issue is coming. Okay. All right. So let me just pause the video and find a quick fix for this. So let's try doing this. It this way. Let's go to Vitis AI and we'll give chmod 777 permissions recursively to the demos folder. So we'll do sudo. Now if we try and create internal server error, so let's close it. Let's quit, and in the Tmux let's conda install lab. Hi. So finally we've got to figure out like how to open the ports and everything. Like it was simple. We were few small errors. So remember in the last session we had created our instance, and yeah. this was the information about the instance. If we go back here and click on view network detail, so in here in the network connectivity test, you will see enable API. So you have to enable that API service, and in here you can see that all the VPC firewall rules. So this is the custom port. So all the protocols and ports are allowed, and priority we had to change from, like, the lower the priority number, the higher the priority. So I gave this the first priority and then the second priority, and now things are working. So I have created a very small application on VS Code of Flask just for the initial purpose. So if I just control save on here and I refresh this, so you'll see this is coming here. Now for the IoT students who are watching from the IoT perspective, we can start building on top of this. So we'll create an AI application using Flask and Pytorch or maybe TensorFlow. And for the hardware software code design students, we'll run an example problem. Okay, so let's just first of all try to sort this Docker issue which we had. So I'll stop the Flask server for now. And inside the Docker images, I can see that I have this Vitis AI GPU TF2 base folder with me, and I will try to expose the ports so that we can access this directly. All right, so for that, cd dot dot Vitis AI. So here we have the Docker run script. So let's just launch it. So if you remember, we had if I open Docker run dot, we had forwarded 2 ports. Okay, so here the issue was that I forgot to actually put a slash in here. That's what was causing the issue. Okay, so I'll press Ctrl S now, and now if I run this base and with the latest tag, so here again, since like we are not committed to the Docker, so things have got Docker ps. So by pressing Ctrl D and then Ctrl A, the Docker exits completely. But if I press Ctrl P and then Q, so we can use just the detach command. It's not work. So some sources suggest online that we press Ctrl P and Ctrl Q, but that is a shortcut for actually closing the VS Code, the application completely. So I'll launch it again quick, ps dot slash. So I think why this is happening with me is that this is causing issue. So I'll just remove the key binding, that's it. Now if I return back to my if I let me try. Okay, so Control P, Control Q. So Control P is again opening this search file name thing. So I'll need to add one. So we've started this again, and yeah, so there was this option of what Control P does. So I'll just remove the Control P here. Okay, so now I'll save this, and let's try it now. Control P. Okay, so now Control PQ has detached me from the Docker image. If I type Docker PS now, I can see that the container is still running, and anytime I want, I can do Docker attach and pass this container ID. So I'll be back into the workspace, and this also helps me in order to commit. If I want to do a Docker commit, then I can do Docker commit. So this time when I install, when I install my packages, I won't just exit or remove it. I would properly close the Docker, right? So for that, let's do conda install Jupyter Notebook. So if I launch Jupyter Notebook now, it will, and I want to launch it on particular port 8888. So for now, what I need to do is type generate config. Before that, I need to do Jupyter Notebook password. So this conda is causing some issue here. I don't know why it is not coming up. So I've just did a pip install right now. So the command for that is also simple. Just pip install Jupyter Notebook. Does it want me to activate? So conda. So it's asking me to put a password. So the password hash is saved in this config.json file. Now we can in the .jupyter and Jupyter Notebook config.json. Do we see this file? Okay, Vitis AI user. So this is my main user. So for that code so this has launched it inside actually. So let me just pull out the command for manually launching the Jupyter Notebook. So I'll just install the command line thing. For that, we'll do sudo apt update, because this Docker image is not being updated for a long time now. So now if we try to do sudo apt install, so it will install a command line thing for us. Now if we head back to ls/user.jupyter, yeah, so we'll see this file, and we can try opening it with VS Code by typing code. So this is command not found. Definitely we can use nano. So now here we can make an edit to the file. So here we want to add, so I've pulled out this document which says we need to allow two things: notebook allow origin and allow IP addresses. So we need to make sure that we do all these. So we opened this file. Just a small fix was required. We had to install. There was this error which was coming regarding no module named import lib metadata. So I just searched for that, and I followed this pip3 install. So after that it started working, and yes, and I cd'd into demos, and yes, it's a Jupyter notebook I launched from here. So I just entered my password and this is now running. So let's try to see whether we have, actually this should not have been the case where it is missing so many files. Let's see whether we have, so it is missing actually a lot of files. So one thing like can be possible is that we have to launch, okay, so yeah, we had to all the time launch the top one and I was launching this base one, so it's my mistake, and I could see, I have seen the file size also. So in here things will not be that difficult. So if mostly I'll get all these things pre-installed in here already. Yeah, as you can see that so it's asking for password or token. As I've not set the password right now, I can do that. So the same configuration file which we had created there, we can create here. Let me quickly do that. Jupyter notebook password, and I'm entering my password. So I can do a nano, and I can, so here this is my hashed password which is stored, and I can just go into the insert mode by pressing I. So here I'll have to type allow origin, and then I have to type in IP as 0.0.0. So yes, mostly this should help us. So pressing escape command and then WQ. So now if I launch the Jupyter notebook, first thing it should just ask for my password. So this is one way, and let's try it IP address. So external IP address is still not working, but anyways we've done the port forwarding. So inside demos we have this IPython notebook. So now you can see that we are able to get all these things properly, and this is like one of the base codes which we have. So you can see how quickly we're able to train the models and run the whole thing, and finally we can even run like the quantization step without any errors. Let's just, so now whatever we download from here, that we can directly get, so you see the quantization step is completed. We have saved the quantized model file, and this is the h5 file, and for our board which we have KV260 board, we're able to generate the X model file. So this is the basic flow of how to do the entire thing on the computer itself. And yeah, so this is the Jupyter Lab version of this. Jupyter Lab is, I find it much convenient to use. So yeah, this is the option for using the Jupyter Lab. Like you can see here all the files, everything, like Jupyter Lab makes it much more simplified. All right, so okay, so that is it for the HSC students. For the IoT students, I'll put one more video about the Flask thing. Thank you so much.